Some important facts related to buffer solutions are that buffer solution can be prepared by combining an aqueous solution, a weak acid and its salt with a strong base, or a weak base and its salt with strong acid. A buffer solution resists change in its pH even if a small amount of strong acid or a base is added to it. A buffer solution maintains the stability of its pH by shifting their equilibrium to consume added H positive ion or replace H3O positive ion, which have reacted with the added OH minus ion. An aqueous solution of a strong acid and its conjugate base as its soluble salt cannot act as a buffer solution, and since the strong acid is completely ionized already, addition of small amount of base will consume the H3O positive ions, which cannot be replaced, and the pH of the solution will change. And if a small amount of strong acid is added to this solution, the equilibrium will not shift to the left because the acid already present in the strong acid. Also, a solution strong base and its conjugate acid do not form a buffer solution due to similar reasons. Some common examples of buffers are acetic acid, sodium acetate buffer, phosphoric acid, potassium dihydrogen phosphate buffer, formic acid, sodium format buffer. Moving on to the applications of buffer solution. Buffer solution play an important role in several industries. For example, they are used in manufacturing of photographic materials, leather and dyes. They are used in process of electroplating, analytic procedures. And the buffer solution are also used for the calibration of pH meters. In nature, many biological systems depend upon their buffer action to preserve constant pH, like the pH of the blood, and whereas the stomach juices also have a pH preserved at 1.6. Milk and egg white show their pH 6.7 to 6.8 and 8.1 to 8 respectively. Buffers are also used to maintain the pH culture media for the growth of bacteria and bacteriological applications. And the composition of buffer solution includes that it can be made by two ways: by mixing a weak salt and a salt of it with a strong base. Such solution give acidic buffers with pH less than 7, CH3COOH plus CH3COO Na. And 2. By mixing a weak base and a salt of it with a strong acid. Such solution will give basic buffers pH more than 7, NH4OH plus NH4Cl.